All right, good afternoon, everyone. So this is the last day we are going to spend on functions. The next 2 weeks we're going to spend on branches, and just an FYI, we do have the midterm coming up on February the 23rd. So remember that is going to be available all day. You will need to have the Respondus Lockdown browser installed if you're going to do it on your machine. If you don't have a machine to do it on, please let me know before the midterm so I can try to reserve one of the labs for you, reserve some space in one of the labs so you can take it there. And what did I want to talk about today? Well, let us talk a little bit more about where you can write functions. So recall when we were going over functions, I kind of blew over one part of it. And that is this part right here, right? Where do we write functions? Where can I write functions? And this is what we're going to focus on today. Let's take a look at JGrasp. Let's start here. So we'll start with our library. Our typical library includes statements. We'll make a main function. And we won't do much right now. We'll just call the print function, hello. So here's a very simple C program, right? We can compile it and run it. But what if we wanted to define our own function? So let's start here. What if, or we'll start up here. Let's just create another function that returns an int, and we'll call it function1. And we don't really need any parameters. We'll just return something. This is just so we can kind of understand. We'll return the number 10. What's going on? So here's my function. I can compile this. I define a function. If I run it, our program doesn't do anything different because I didn't call it, right? That's okay. We know how to call functions, right? I can call functions by typing in the function name, followed by the parentheses and any required parameters. Do we have any parameters to function1 here? No, we don't, right? We know that because there's a blank space between the two parentheses. There's nothing there. That's where we would put our parameters. Does function1 return anything? Let's take someone on the right side of the room. This function1 here, does it return anything? That's right, it does. It returns the number 10. How do you know that? Because it has the number, the word return right here. Very good. Let me ask another question. If I change this to that, and I ask the same question, now does function1 return anything? Yes or no? Oh, you all are sharp. Okay, very good. So I'm glad to see. I'm shocked. I'm pleasantly shocked. Very good. In the past, that's usually a 50-50 question there. Many students don't understand the difference in the past between printing, displaying something on the screen, and actually returning something that can be used later in your program. So that's very good. I'm actually very happy about that. Let's go back to the way it was. So we'll say return 10 int, and here we'll just print whatever gets returned. I'm going to print a number. And call the function, and whatever that function returns, that's what I'm going to print. All right, so we can compile it now and run it, and it should print hello and the word 10. Very good. So what if I were to move? So here we're starting to get into interesting stuff now. What if I move this function down here? Now we just ran it. I had previously defined it and it ran just fine. Let's try to compile it. I'm going to clear this out. Let's try to compile it. And we get an error message. What's the problem? That's right. So functions aren't that different than variables in this regard, in the fact that the function has to be either defined or you have to declare that it exists before you can use it. So we know what one option is. I could move the function back up here and just have the definition before I use it. So I want to use it on line 8. I need to define it before line 8. Or let's leave it here for now. I could simply include my function declaration. And in C, a function declaration is just the first line followed by a semicolon. Simply put, that's not exactly correct, but it could work. You could literally just copy the first line of a function, add a semicolon to it, and that's good enough for a function declaration. So here we could compile it, and notice it doesn't complain now. And we can run it, and the same thing happens, right? It prints something. So that's great. Well, remember that we said you don't have to write all of your functions in one file. They don't have to be written here. If I wanted to, let's make a new file. Let's say new C file. And we'll just call it file 2. Oops. We'll call it file 2. So file 2.c. And what I'm going to do now is take this function out of here and move it into this file. And I'm also going to, well, we'll just leave that there for now. So let's, now, if you're going to do this in JGrass, you have to drag these down to, you have to drag these C files into that project. So here's my project file. Otherwise, it won't recognize the other file. So let's go ahead and do that and compile it. And we can see that it's, let's clear this out. Let's compile it. And we see it doesn't complain. So let's try to run it and see. Well, I wanted it to not work. JGrass did some stuff for me it wasn't supposed to. But anyhow, so because I had this declaration up here, it didn't complain. And because this is JGrass linked everything correctly. But what should have happened, let me just erase this. Now we should have problems, I hope. There we go. Now we have problems again where it can't find function 1, right? And it was okay previously because we had that function stub up there. What should have happened when I ran it, however, it should not have worked because I did not include the header file. I didn't tell C where to get where that file was. JGrass did it because I put them both down here in the source file. I said, oh, these belong together. We should compile these together. That's great. But you can see here we have the same problem, right? It can't find function 1. And the reason it can't find function 1 is because it's in a different file. I have it defined here. And of course, it's not declared. So what could we do now? Well, if I want to include a function that I wrote in a different file, we would do something kind of like this, right? So here, when we include the standard IO library, what we're doing is including a bunch of functions that someone else wrote in a different file, right? We could do something like this, but we're going to use quotation marks and not the brackets. So brackets, you only use those for built-in libraries, the ones that come with C. Anything else, you have to use quotation marks and you can tell it where it is. So right now it's in f2.c. Oops. So let's save it and compile it. And oops, let's go back here. Hey, what are you complaining about? It should not complain about that. All right, let's do if not defined. Let me put my if not, okay, I was right. So if not defined, we'll do test one. Let's see if this fixes it. It's still complaining about that. All right, I give up. Well, what we really need to do here, I should have a header file. I wanted to work toward that. It is possible in C to include the actual file itself that has the functions. That's not the way you're supposed to do it. What you're supposed to do is make a third file. We'll make a header file. Okay, we'll just do C for now and save it as functions.h. We'll just call it that. And what we put in here, this is where we put our function declarations. All right, so we'll go here into this one. This is where we put our function declarations. And then inside of our files, we would include that header file, indicating that here's where I got a bunch of function declarations somewhere. Here's where they are. This is what I want you to use for these function declarations. And then later it can, identify the function of this file. So notice it's happy now. And if we were to run it now, it can still find and use that function, right? So instead of having the function declarations at the top, like this, what we want to do is put those declarations somewhere else like this. And then we can just reference that header file everywhere. And that will suffice for all of our function declarations. And then when we need the functions, we have the other files. Eventually we'll compile the other files and we'll have the instructions we can use. So if we want, we can have multiple instructions. Would function 2, function 3. We'll just make 4 different functions. And perhaps we put 2 of them here. Maybe this one just returns 20. And then we can have another file that has the other 2. We'll just return 30. Grab this down here. So here, let's do this, and we'll just call this a couple times, right? So we'll do %d, 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 and we'll call function 1, function 2, function 3, and function 4. So we have multiple functions. They all exist in different places. They're not all written in the same place, but we've all the declarations here. Everybody kind of shares that. And now we can compile it and run it, and we can use all those functions, even though they're not written in this file where I'm running it from, right? If we go to Canvas, right, I have a couple of examples here on Canvas that kind of try to demonstrate that. And if we go to Vocarium, I want to take this time. Well, let me stop. Do you all have any questions for me before we continue? Any questions? All right, let's go to Vocarium really quickly. And recall I mentioned that from now on, your homework assignments will look different. So I wanted to spend some time explaining this idea, because this is how we're going to do our homework assignments for the rest of the semester. It is important to understand this anyway, but this is typically the way we would write a program or structure it. But it's also important because we're going to do our homework that way. So if we take a look here, so from now on, when you all have your homework assignments, you'll see something like this, main.c. And for the most part, you should not touch this file. You can if you want to, but you shouldn't. This is my file. This is let's call it a pre-test. This is not an exhaustive test of your work, right? But if you run this and your code compiles and it runs successfully and you didn't change anything, there's a good chance your code will pass all the tests when you submit it. I say that because every semester I have someone come and change this file and say, well, it worked when I ran it, but you changed the file. When I test your code, I'm going to use something like this that you don't have the ability to change. And if you've made changes here, it's possible that, you know, those won't be reflected in my tester main.c file. So, but if you look at this file, what you'll see is I'll call some functions like calc fib n. And if you look in this file, you'll see that that function is not defined here, right? Where is it defined? Well, you're going to do that. That's a function you have to make. That's why we don't see it here. We'll call this something like this calc resistance. And if you look in here, you won't see it defined here because, well, you have to make that function. You have to define that function. Same thing for this one here, right? And if we look in our header file, you'll see some things. You'll see two function declarations. So I will always give you the header file. So I have given you this header file. And notice here, you should not modify this file. In general, you should never touch this file. Now for this assignment, this piece down here is extra credit. So if you want to try the extra credit, you can play with this, tinker with this down here. But I wouldn't do that until you get 100 first. So Vocarium will save your highest score. Get 100 first and then go for the extra credit, okay? But here are two function definitions, and you have to write those functions. Where would you write them? Well, you're going to write them here in the homework2.c file, just like we did here, right? I've got a header file that has some function declarations in it. But then in these other two files, this is where I provided my function definition. So you're going to do something like that for the rest of the semester. Here, we're going to go to homework2.c, and you'll see that I've kind of got you started here because this is our first one, right? This is the first homework assignment where we had to make a function. So I kind of got one of them started, but not the other one, right? If you look at the header file, and if you read the instructions, you're supposed to create both of these functions, right? Typically, this would be empty. And so after this assignment, this file is going to be empty. I'm not going to do this again. I'm only doing it in this one because we're just getting started. It's still new. I'm trying to help you a little bit, just show you kind of what you're supposed to do, right? We're defining a new function. Here are my parameters, and this is I've just stubbed it here. What does it mean when I say stub it? I stub it, so if you stub the other function, you hit the compile button, it'll work, it won't crash, it won't return the correct result, but this does return something which is good enough for this to compile. If that makes sense. Your program must compile without errors. If there are any errors in your code, it won't compile at all. Right? All right, do you all have any questions for me so far? Any questions? Well, that was all I had for today. Anything you all want me to kind of demo or demonstrate for you regarding functions or anything up to this point? If not, I'll see you on Wednesday. We'll begin talking about selection, I believe, is the next topic. Selection or branching? Yeah, branch of selection. All right, have a good evening, everyone.